You know what's really cool? We're next and we get to do this. What's really cool, we're going to talk about a whole bunch of testing things. We'll do unit testing, and we're going to start slow creating new unit tests, but we're actually going to do some really, really cool things as we get through this. We'll start mocking things. We'll use dependency injection and tests. It's going to be really fun. Here's the part where I tell you, I am definitely going to post the slides on my blog tonight, but in this talk, there are no slides. That's it. There's my slide. Woohoo! What's really cool, though, is the code that we're going to do today is online right now. There's a start folder where we'll begin, and there's a done folder where we'll end up. And so you can download this right now and get from where we'll start to where we'll finish. And wow, my network connection is toast. But it's really cool where you can start and end and get to exactly where we are. So that is online right now here on GitHub. That URL is a little hairy, and so if you want to, head over to robrich.org, robrich.org, click on presentations here at the top. Here's .NET testing best practices. That will get you straight to the GitHub repository. While we're here on robrich.org, let's click on About Me and see some of the things that I've done recently. Docker and Microsoft have both given me some awards. I get to do some really cool things with Redgate and Cypress. I've gotten to write some books, which is cool. AZ GiveCamp is one thing that I'm really proud of. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver that completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp here in Sweden or wherever you traveled from, find me here at the conference or on any of the socials, and let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, I got to work on the Gulp project in version 2 and version 3. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woo! So there's my claim to fame, my coveted .NET Rock mug. And if you'd like a .NET Rocks mug, no, I'm just kidding. Yeah, music to code by now. Cool. So let's start here where we began, and let's take a look at this light controller application. Now, this is a subset of an application, an IoT app that listens to a light sensor and is able to turn on or off a light. And so here's that light switcher interface, and we've got an instance of it. We've got this motion sensor interface, light actuator, and here's that light actuator. I'm glad we're using interfaces so far. Here's that actuate lights method. Now, this is the method that it's our task to test today. We take in whether motion was detected, we update the last motion time, we then get the time period based on the content out here. Ooh, mood lighting. And so we get to see if we should turn that on or off, or what time of day it is, given that time period. If it's dark and motion was detected, then we'll turn it on. And if motion was not detected or it's light, then we'll turn the light off. Now, the interesting thing here is that this is not a stateful light. We may turn it off when it's already off, and that's okay. So we have then a program that rigs that up where we just, in this case, I just have a fake one that turns it on or off every second or so. Then we'll just have a thing that will write to the console whether I'm turning it on or off. And then we have a main method that rigs it up just so that we can kind of see it functioning. But our quest today is to write the tests around this. So let's start off creating a new project. We'll create a new project here and we'll switch to testing. And that will filter our list down to just a few. We could use MS Test or NUnit. I'm going to use XUnit in this case. XUnit is the testing framework that the ASP.NET team uses to test ASP.NET. That's enough of a recommendation for me. I like that. So let's create an XUnit test project. I've got one right here. And now let's create maybe a starter test in here. I'm going to say add new item. Hello world. And here in this test, let's create some test stuff. File scope namespaces for the win. Public class hello world. Public void test hello world. Oh, that's interesting. My secondary screen turned off. Oh, and my primary screen turned off. That was really entertaining. I might have a loose HDMI connection. Am I back on? I am. Cool. So I've got my assert statement here. I want to assert that true equals false. And of course that's going to fail. So let me set this to true and true. Or I'm going to say int expected equals 7, int actual equals 5. And then I'll validate that expected equals actual. Or wait, no, it's actually actual and expected. Or is it the other way? I spent a really long time one day trying to debug a test because the build said, hey, well, I expected 7 and I got 5. And I debugged it for a real long time and I'm like, but I got 7 and you wanted 7. Well, I actually had these backwards, actual and expected, because it's actually supposed to be this way. Or is it actually, what, did I have it right the first time? I don't know. Let me introduce you to Fluent Assertions. So I'm going to come here and I'm going to add a new NuGet package, manage NuGet packages, and I'm going to add Fluent Assertions. What Fluent Assertions allows us to do is to say actual.should.be expected. I never made that mistake again. Woohoo! Fluent Assertions. That just reads really nicely too. Now, the cool part is should is an extension method that takes in an object. So if this is null, then I don't get an undefined null reference exception because, yeah, this extension method can take in null and it does just fine. Cool. So let's run our test. Well, I'm going to come here into the test menu and I'm going to pull up the test explorer. I've got it down here and if it builds first, then I come into my test explorer and I can take a look at my tests. Let's run. Oh, it's in the middle of building. Built successfully. Now that is definitely too small, but let's run all the tests. And we can see that we now have a failing test. Now the cool part about this failing test is that we can see what line failed and, oh, it's still running. Oh, haha, I missed one piece. Fact. Now this is a test. I actually have a unit test that reflects on all of my test classes to see if any public methods don't have the fact attribute on them. And that test fails if not, because I have done that part a whole lot. I go to commit my code. I've got all my tests ready to go. They just don't have the fact attribute. And of course, all my tests pass because, well, none of them are running. So it tells us nicely that, well, I expected actual to be 7, but I found 5. So let's set actual to 7 and rerun our tests, and we get a green one. Great. Test went green. Let's ship it. There's a really cool thing in here that also allows us to be able to run tests after build. And the cool part here is that that will rerun the test whenever we finish a build. There is a thing called live unit testing, and that isn't this. But this just run after build. If your tests run really quickly, it's nice to kind of kick them off all the time. Okay, so let's create some light actuator tests. I'm going to create a new file here, add new item, light controller underscore light actuator. Nope, light actuator underscore actuate lights tests. Now I've named it to match the class that I'm going to test, which is really cool. So now we can see that the class that I'm testing is light actuator. The method is the actuate light method. And so I can just really clearly see the method that I'm going to test just from the name of my tests. Let's make this public. File scope namespaces are awesome. Global usings are also awesome. Now, what type of test do I need here? Well, let's say I want to test motion detected is true. Update last motion time. That one sounds like a good test. Let's test the negative of that. Motion not detected. Don't update last motion time. Great. Then if it's dark and motion detected, turn on lights. If it's light and motion detected, don't turn on lights. If last motion time within a minute and dark, turn off. Nope. Yep. Turn off lights. Nope. Leave lights on. If last motion time after a minute and dark, turn off lights. And if it's light and no motion detected, turn off lights. If it's light and motion not detected, yep, there we go. So there's our list of tests that we want to build. We've looked through our code and we've kind of seen the scenarios. And so this then becomes a great setup for all of our tests. Now, next I want to go create a method for each one. And I started off that one. So public void that. And let me put the fact attribute on there. In NUnit and MS Test, it's called test. And in XUnit, it's called fact because naming is hard. So great, I've got a test. And right now my test will pass because there are no assertions that fail. That would be a bummer. So I actually say throw new not implemented exception. And I'm going to do that inside every test so that my test doesn't accidentally pass before I've written the test. Let's do that again for the other case. Public void motion detected false. Thank you, GitHub Copilot. It's seen me do this demo before. So we've got that test. Public void dark and motion detected. Turn on lights. Well, what I have here in my application is I have this that's evening or night or morning or afternoon. I may have to write 4 different tests for this to kind of get each of the scenarios that I want. But really the only difference between this test and the regular and all of the other tests is the parameter. So I really want to take in a time period. And then I can do all of those tests in one go. So let's do that. Let's say inline data, I want to take in morning. And what I expect to do in the morning, well, I'm not going to turn on the lights. So time period, bool expected, turn on. Let's do afternoon. It's not dark in the afternoon. Evening, I do want to turn on the lights there. And at night, I do want to turn on the lights there. Hey, that's pretty cool. We were able to create one test that now has lots of scenarios, and I can then pass in that data to be able to run really interesting things. One of the things I like to do is go grab the last saved record out of the database and play it through my intense algorithms again and make sure I got the same answer. And the cool part is it'll just read that last thing and inject it into my test. That can be a really great way to do that. So we did that if it's dark and motion detected, and we did that if light turn off. That's great. We did it in one go. Well, let's start implementing these. We may not have time for these last ones, and that's totally fine. Motion detected true, update last motion time. Let's talk about the arrange act assert pattern. Now, the cool part is we can set up what we want to test. Oh, I deleted my throw new not implemented exception. GitHub Copilot knows that I shouldn't do that yet. I want to set up my scenario and then flex the conditions that it's actually going to do and then validate that those conditions exist. So I can kind of build these into 3 separate things. Now, we didn't talk about test-driven development. That's definitely a good move to make if we want to be able to discover the APIs that we're trying to build. We can just build our tests and then actually implement the code that'll solve that. But instead, let's test drive our tests. So I want to act. I'm going to say light actuator equals new light actuator. What am I going to do? Well, I'm going to actuate lights. True is interesting, but like, what does true mean? Really what it is motion detected. Excellent. And so now I want to update last motion time. So let's go grab last motion time. Date time last motion time, or I'm going to even say actual equals light actuator dot last motion time. That's what I need to act. Cool. Now that I'm acting on it, well, what do I want to assert from that? I want to assert that actual dot should not be or be after original. Original spelling is hard. There we go. Cool. Original motion time. So now that I've got these in place, now I know what I need to be able to set up to do that. Well, one of the things that I'm saying here is motion detected is true. So let's do that first. Motion detected is true. We want original motion time to be something old. So new date time 2000. Ooh, I lost my secondary screen again. I wonder if I'm about to lose this one. Yep. Poof. Am I back? Cool. So now that we've set this up, well, what does 2000 mean? Something not now. That'll help us kind of get a feel for why this value was. Okay, so if we were to build this, we can see that we now have a build failure because last motion time is not public. Let's flip back over to our application. Last motion time is private. Now we have a few options here. We do want to be able to set our last motion time. Oh, actually, we do set our last motion time right here. Light actuator dot last motion time equals original motion time. There we go. We could do some friends visible to mayhem inside here to say, I want to be able to access protected members. We would need to create an attribute inside this class to be able to get at that. But I'm going to take kind of a more low-tech solution here. I'm going to say this is public. Now, as public, it is not part of the interface, so our consumers won't have access to it. They won't be able to use it. That's good. But I'm also going to document this public for to be testable, not part of interface. Cool. So because that is public there, then now I can get to it in my tests. That's perfect. And now I did need to modify my production code, but it allows it to be much more testable. And I very carefully documented it because somebody's going to come through later and go, oh, we forgot to add it to the interface. Let's just add it real fast. No, actually, it's specifically not supposed to be part of this interface. Let's leave that off. Cool. So let's fire up our Test Explorer and let's run all of our tests. We now have some new tests. This window is definitely far too small, but we should be able to see the reds and greens come. Yep, we've got a whole bunch of reds. And let's take a look at this test. Motion detected. True. Update last motion time. And it's telling us light switcher is not initialized. I'm not testing light switcher. Why is this a thing? Well, what we can see is that, yes, we did update our last motion time, and then we fell into this method where we're coming to lightSwitcher.instance. LightSwitcher.instance tells me that lightSwitcher is not initialized. Well, what we did here is we created this singleton pattern that allowed us to be able to get at this light switcher, but that really doesn't help us test it. We really want to do this each time. So I'm going to yank this out of here, and I'm going to delete this whole singleton thing. And instead, I want to take in one of these light switchers here in this class. Default constructors for the win there. I don't need to do a whole lot of public constructor. It just does it. And now let me go grab the light switcher instance that I got injected in. And now I can do what I need to do here. Now, I do need to modify my production code here. No longer am I saying light switcher init. Rather, I say light switcher, or light switcher, light switcher equals new light switcher. And I'm going to, light switcher instance needs to descend from the correct class now, and I need to pass that light switcher in here. Cool. I've modified my production code. Let's go modify our test to work as well. I need to pass in this light actuator. Well, I don't care about this, so I could say public class light actuator mock implements light actuator, and then I'll just, I don't know, get it to implement the interface. Oh, that's not what it wants. It wants a light switcher. Light switcher, light switcher mock, and let it implement that interface. I don't know what I'm going to do there, but I don't know. Let's do the thing. And then I could pass in a new light switcher mock. That was kind of a lot of work to get to this process. Could I just, automagically build one of these things that implements the interface? Let's delete that. We can go look for a library that can do this. And so what I like is mock, M-O-Q, or mock-U. N substitute is another great one, where I can just say, hey, I've got this interface. Can you just go build me one? And it will go build that interface and implement it in the ways that it needs to. So let's do that. I want to say mock light switcher equals new mock light switcher. If I'm using N substitute, I just pass in light switcher. But if I'm using mock, I do .object so that we don't pollute the original object with all of the mock's verified methods. And now that test will pass. Let's run this test. And we'll see in the Test Explorer that now that test goes green. Great. Now, I didn't need to worry about light switcher. I just kind of set it aside. It's not doing anything relevant to me, and so that's perfect. The cool part then is I can take this content, put it here, motion detected as false, and this should equal, nope, should be original motion time. Now, because it's a date time, I might have to say within whatever if I'm serializing it and deserializing it to store in a database. But let's do this one. Let's run that test. And this test should go green too. Cool. Any questions thus far about the mods we needed to do to our production app or setting up that mock? Cool. Well, let's dig into the next one. Now here we say motion is detected. So motion detected, true. We still need to set up our thing with something not now to be able to do that. But then we also need to be able to say, here in my application code, I need to be able to set time period. Now, right now, time period comes out of this private method in here that's doing this time period stuff. And so there's really not a way for me to inject this time period into it. What I really want to say is light actuator dot time period equals time period, and that's not going to work. Instead, let's take a look at another technique that we can use. This private method really could be a different class that we inject into it. Let's set this up as a different class. Public class time period helper. And now that we've got that public class, let's make this a public string here. Let's implement time period helper. I love this doohickey extract interface, and we could add it to the current file or to a new file. In this case, I'm going to add it to the current file right here, but probably I would move this whole class then to a different file. So now we've got this iTimePeriod helper that has this getTimePeriod method. Let's inject this into our light switcher, iTimePeriod helper. And then instead of calling this directly, we can say TimePeriod helper.getTimePeriod. And we've now got this elegant way of getting that time period. Cool. So now in our application code, we do need to inject in a time period helper. I'm getting tired of doing all of this, voodoo of setting up the things. Don't we have like a gadget where we can just say, here's the thing and automatically rig it up? Well, if I was in an ASP.NET project or if I had built a worker console app, then I would have that in place. But upgrading this app, I might want to say, well, let's use dependency injection in a console application. Cool. Well, what I need to do is spin up this. I need the reference to Microsoft Extensions dependency injection. And then I rig up this service collection. And the cool part about this service collection is that we'll get, let me yank my notes off screen. Service collection. There we go. Let's go build a service collection here in our application. So we can say var IOC equals new service collection. And yeah, typically it's called services. And then let's go rig up all of our things in our IOC container. And then let's go say var IOC equals services.build service provider. And then with our IOC container, let's use it as infrequently as possible to be able to go get the thing that we need. We no longer need to worry about when we modify the parameters of things, it'll just automatically go find it and we can do what we need to do. Perfect. Let's build our production application. and everything works great. Now back to our tests. We can take a look at these tests and, well, we still need to modify this one. Throw new not implemented exception. Not done yet. Don't pass by accident. But let's come back up here. Oh, this light actuator needs a... Do I have to play this game? Can I use an IOC container inside my test too? We use IOC containers in our production app to do all the things. How do I use IOC here? That's where we can use AutoMocker. What's really cool about AutoMocker is we can say to AutoMocker, I want to get this thing, go fill in all the dependencies. And AutoMocker will say, well, do I have a mock created yet? If not, let me just go gin one up real fast and do that. So let's do that. I'm going to say right here in our original test, I don't care about that mock anymore. I want to say var IOC equals new AutoMocker. And then here I want to say, hey, IOC, can you get me a new light actuator, please? And go fill in all of the dependencies that you need. I don't really care. And so now I've got dependency injection in my tests. That's really cool. Have you ever had to go modify your test because you modified some parameter in some constructor and you just had to run around for the next like 2 hours updating all of the tests because it's like AutoMocker. Let's do that here as well. Let's AutoMocker. Should we parameterize this test? That might be a good idea. You know, we learned that technique here and that was really cool. I'm going to leave them separate just so that you can see the difference. But yeah, that's pretty cool here too. Let's do that. So I have that IOC, and now I need to set up that time period helper. Okay, so let's say var GitHub Copilot knows where I'm going here. Let's go create this time period helper, and we just reached into the IOC container, and it said, hey, I don't have one. Let me gin one up real fast. Time period helper dot setup. When I have that time period helper and you call get time period, I want to return this time period. Now I need to take in some date time, so I could say original motion time, but that's not the date time that you're going to pass in. You're going to pass in datetime.now, so I could say datetime.now, but well, is that now or now UTC? Has it been a few milliseconds? I just want to say, hey, if you've got any date time, that's going to be fine with me. If you pass in a date time, then let me return this time period helper. And I love that that is kind of like a generic parameter, but now I get compile time support against my mocks. If I'm using something like Rhino mock with, you know, string matching and I go to refactor my code, then that can get really scary. So I've set up my time period helper to inject that time period. And then I can say, so did it turn it on? Well, now I need to go reach into this light switcher. So let's go build a light switcher mock. Var light switcher equals go get that light switcher. And I want to do a similar thing where I've got this mock doing stuff, but I want to say light switcher dot setup. When you call turn on, I want to call this callback, and I want to say actual turn on is true. That's the method that I want to call when you call turn on. Okay, so let's set up bool actual turn on is false. I'm going to move that up here to the top because that's kind of important. And now actual turn on should be expected turn on. Cool. I think we're done. We set up two mocks. One to be able to inject the time period, one to be able to harvest whether you called that turn on method. And so that's a little bit heavy, but it may make sense to move some of those to helper methods, but it's not too bad. Now let's build. And do we build successfully? How many typos did I do? Ooh, Yes, when we have inline data, facts should be theory. Thank you. Yeah, naming is hard. In both NUnit and MS Test, it's just called test all the time, and that's helpful. So now let's run these tests. And now we see that our original 2 tests will run green, and this test will run green as well. Woohoo! Ship it! It's working! Cool. So now let's take on the next one of doing if it's light and so now motion detected is false. Light and no motion. Turn off lights. Expected turn off. In the morning, I want it to do it. In the afternoon, I want to do it. In the evening, I want to not do it. At night, I want to not do it. And this is actual turn off. It is the turn off method. Off and off. Cool. That was pretty cool. Couple of find and replace, and now we're calling the other one. So should I create a generic method that allows me to set up either turn on or turn off? I could, but now my test is going to get kind of intense because now I have this setup method that takes in a bunch of parameters and I have an if block. And so I'm just going to leave it here because I don't want to have some super complex thing hidden away from me that makes this test not really very discoverable. One of the goals of tests is to be simpler than the implementation code so that I can just look at this and I can go, yeah, I think it's doing what I expect. So I'm not going to abstract that away. I'm just going to run these tests, and let's take a look at how that works. So we built successfully. Let's run our test explorer, and we got some red. Ooh, what happened here? Expected turn off to be false, but found true. I think that was because I don't know what that was. Oh, if the last motion time is greater than a minute. So this needs to be date time.now.add seconds -1 within a minute. Okay. Let's run these tests again. That might be a little bit better. Cool. So we've got now our test explorer, and we've got a red test. I don't know why that's happening. Let's actually set a breakpoint right here, and let's go debug our tests. I'm going to do debug tests in the same way we've been able to run tests, and now we can take a look at it. Now, I'm not sure what time period it picked. Did it pick? Oh, it picked afternoon. Excellent. So F11 to step into it. F10, last motion. The time period I got is afternoon. That looks great. Motion was not detected. So now if the time period is morning or the time period is noon. Oh, if the time period is noon, not afternoon. My test helped us find a bug here. We've got this noon, not afternoon. Well, I can change it like that, and that would definitely make my test pass. But let's take a look at this again and see what we did. We have a magic string that is causing a build failure, runtime failure. And we really want to turn that into a build time failure so that we can see some interesting things. Instead of returning a string here, let's return a time period. Let's create this time period, public enum time period, and we'll say morning, afternoon, evening, and night. We'll then return time period dot night, time period dot morning, The demo gods are not with us today. Time period dot afternoon, time period dot evening, and now we can return a time period here and then modify these and these. The cool part is that this is just an interface between these two classes. It's not anything to do with the public interface that any of our consumers will use, so we don't need to modify those. Oh, I need to get this one to return a time period as well. And so now we can see that that is a compile time fail, and we can say afternoon, and away we go. Now we do need to run around to our tests, modifying this to time period dot, and then our test will pass. We just found a production runtime bug that we were able to move into a compile time bug to be able to then solve that. That's cool. Now, for the sake of time, I'll skip these last ones, but I would definitely invite you to implement them here on the GitHub repository. You can see that they are in the done folder, but let's take a look then at this workflow, this GitHub Actions workflow. Now, we do want to run our tests as part of our build, so I'm just going to say .NET test here in the build. Now, I do want to grab my output results, so I'm going to look here at this test reporter. This test reporter will be able to go harvest the test results. Now, in this case, I chose JUnit format. I chose JUnit format not because this is a Java project, but because JUnit is a standard test format that every dashboard knows how to use. So let's harvest those test results in JUnit format, and then let's publish them always, even if the build fails. I hate it when I forget that part because it's like, I publish my test results when they succeed, and when they fail, I don't know why. So let's publish our test results, and then if we run that build, we can see that we've got our tests, and we've got our test results, and all of the tests will tell us what happened. This is really cool. So the cool part is that this code, both the start and the done, is up on GitHub right now. You can head to robrich.org/presentations, and you can grab this code, both the start and the done. This was a lot of fun to get to show you .NET testing best practices. Thanks for coming.